All right, you guys, here we are with day 2 of our first day of our limits chapter. So I'm just picking up right where I left off in the notes packet, but I have a little bit of a recap to start with just to refresh your memory. So there's a little bit of repetitiveness to help you kind of learn some of this new stuff and these new concepts. But in order to find the limit when you're looking at an actual graph, so like a parabola or a weird piecewise graph on a coordinate plane, ask yourself these 2 questions. And again, if I go too fast, then just pause the video and copy these down. But is it approaching the same value from the left and the right? It's got to be approaching the same exact number. So remember the analogy, if I'm like standing at the board and I'm tracing with my left hand the graph, and then I'm tracing with my right hand the graph, and I'm approaching a specific x value, are my hands going to meet? Or are they ending in different places? So that's how you decide if the limit exists or if it doesn't. Okay, are they approaching the same value? Or are they approaching different values? Are my hands going to touch or are they not going to? If it does approach the same value, then that means yes, then that is the limit. The y value is what you report, is the answer. Whatever y value my hands are meeting at is the limit. And if my hands don't meet, if they are like one's up and one's down, or they're different locations, which I'll review when we look at some examples below, that means the limit does not exist. So let's be like politically correct with our calculus lingo here. You don't say things like no solution or impossible or empty set or anything like that. You actually technically say the limit, DNE. Remember, that means does not exist. And so the second part, find the limit given an equation. You can just copy these things down. We haven't really looked at any examples like this yet, but we will in just a second. But it works kind of the same way. Instead of looking at a graph, you're actually looking at an equation, like an f of x equals some equation. You're going to plug the x value into the left side and the right side. We'll talk about that in a second. Again, if it's the same value, then it exists. You report that y value as your answer for the limit. And if it's different values, the limit DNE. So again, works the same exact way for a graph or an equation. We'll talk more about some equation problems in just a second. But what if you are asked to find the limit given a table? So see if you can tell what the function is approaching from both sides. That's what I ended the video with yesterday. So remember, we looked at like as the x value is getting closer and closer and closer to a certain number, that's the limit as x approaches whatever. That number, find that in the table and see if it's approaching the same y value from both sides or if it's different values. So you should be seeing a theme between these 3 different bullet points. If it's the same number, the limit exists. If it's different numbers, the limit does not exist. Okay. I already have my answers and stuff written out here just so my work would be a little bit nicer and neater, but what I want to show you is like, first of all, how I got this graph, and then we're going to evaluate the limit. And once you have a graph to look at, it's much, much easier to be able to evaluate the limit. So this very first thing, here's my first graph. Always do a sketch of these piecewise functions so that you have something to look at. This equation, y equals negative 2x plus 1, so that's a y equals mx plus b. It's a straight line with a negative slope starting at positive 1, so that's why I put my y-intercept here at positive 1, and then I went down to right 1, down to right 1, down to right 1, and that line, you know how lines continue forever, but they told me to only start it at 3 and go to the left. And so that is why this should be a closed-in circle. My bad. Fix that. That is why that section of the line starts at 3 and goes to the left. So you could have also done a t-chart and started with 3 with a closed circle, plug in the 3, you get negative 5. That's exactly where I started that line, 3 comma negative 5, and then the slope of negative 2, and you're only using x values less than 3. So you're using 2, 1, 0, negative 1. That's why it's going this direction. So this is the piece of this linear function that starts at x equals 3 and goes to the left. Okay, and then after that, remember that this negative 5, this is just a horizontal line at y equals negative 5, which is down here. But they don't want the entire line. They want just a piece of it starting at 3 with an open circle right there. That's okay because I already closed it in. So just remember that it can't be closed for both. That would make it not a function. So it's open for one, closed for the other. That part is okay. but it's just a horizontal line at -5, and that goes x greater than 3. That means it goes forever this way. So it's okay to put an arrow there. So now we can analyze the limits now that we have the graph to look at. So first of all, x is approaching 5. It doesn't say from the right or from the left. Remember, there's no plus or minus up there. So as it's approaching 5, I'm going to look at from the left and from the right. And so where even is x equals 5? It's not even on my graph, so I'm going to go like this. It's basically right here. So think about me standing at the board, tracing this graph, approaching x equals 5 with my left hand and my right hand. So my left hand is approaching. My right hand is also approaching. Are my hands going to meet? Yes, they are. They're approaching the same exact value. What is this value here? Remember, you always report out the y value. So when x equals 5, my left hand and my right hand are both approaching -5. That's what this y value is down here. So that's why I have -5 written as the answer for the limit. Okay, let's look at 3. So 3 is a different x value. I'm going to go to 3 here. It's right there. So okay, cool. As my left hand is approaching this x value, it's coming down this roller coaster like this. And as my right hand is approaching, it's on this flat line here. See how my hands are going to meet as I move them across the graph, approaching 3 from the left and approaching 3 from the right. They're going to meet right here. You can kind of think about this as cars driving on a map. You're like in a drone looking at Google Maps or something, and you've got one car approaching from one direction, you've got another car approaching from another direction. They're going to meet. At what y value are they going to meet? -5. So again, we have the same answer there, -5. So look at number 20. So I've got the sketch already here. So this graph is just a basic parabola centered at 0, 0. But they only want the piece of the parabola for x values less than 2. Notice how these are both open circles. So that's why I have an open circle here and an open circle here. So for x less than 2, that means that my parabola, which goes through 0, 0, that normally looks like this, I have to cut off this part of the parabola and start it at this x value of 2 with an open circle. And that goes x less than 2, so that means that I'm using all of this parabola as part of my graph. And it's okay to have an arrow here. In fact, you do need an arrow here because it's x less than 2 forever to the left. And then I have an absolute value graph, so this is a V shape. And remember, this -4 inside the absolute value bars means to the right 4, 2, 3, 4. So my vertex is right here. And normally this V looks like this and it goes left and right forever, but they're telling me to only do the V for x values greater than 2. So that's why I don't have an arrow this direction. I have an open circle on 2, and then it continues to the right forever. So that's how I did those two pieces of those functions, a parabola and a V shape. And the parabola is only for numbers less than 2, and the V shape is only for numbers greater than 2. Now let's see if we can analyze the limit. As x approaches 2, remember I have to look at both sides. As x approaches 2 from the left, I've got this car working on this parabola-looking map situation. It's approaching. It gets really, really close to the y value of 4. That's where this car is going to end as it approaches the x value of 2 from the left. Here's the x value of 2, so we're going this direction. And what about the car that's working on the V-shape part of the map? As it's approaching from the right, it's going down, and then it takes a turn, and then it's approaching what? Where does it end? Right here at 2. So the first part, as it approaches from the left on the parabola, it gets close to the y value of 4. The V-shaped graph gets close to the y value of 2. Those are two different numbers that it's approaching. My hands are not meeting if I'm standing at the board. My left hand is ending up here, and my right hand is ending down here. That is a huge gap in between my two hands. The limit does not exist. Let's look at -1. If I'm approaching an x value of -1, which here is -1, so I'm kind of only looking at the parabola for right now. Let's think about two cars. As the car is approaching from the left, this red dotted line, it's getting close to a y value of 1. As the car is approaching -1 from the right, it is approaching a y value of also 1. My left hand and my right hand are going to meet right here. And what is this y value? 1. So that's how we do these limits. I've got a couple more to talk about. How about if we look at this parabola? This is a parabola because it's a quadratic with an x squared. This means left 1, down 3, so I can get my sketch of my parabola right like this. And I just did a brief sketch, so left 1 and down 3 is where my vertex is in my parabola, and just do a couple points here so that you can get your U shape. It's positive, which means it's pointing up. And so now let's analyze the limit as x approaches -3. Let's look at it by just doing the graph. In this case, as I approach x equals -3. Where is -3 even? Oh, it's right here. Okay, and so my left hand is on the skyrocketed part. It's coming down, 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 down. Gets to a y value of 1. My right hand is coming up, and my hands meet right here at 1. Let me show you a pretty cool thing. If there's only one equation, this is what I was talking about in the table above. See how there's only one equation here? So they're not looking at like two different pieces of a graph or anything like that. When there's only one equation, it's okay to just plug this number right here, -3, into the equation. When you plug in -3 here, this becomes 4 minus 3 is 1. That's exactly what we got by looking at the graph. So in the event of, this is when you're given an equation. When you're given one equation, that's kind of what I was talking about up here. When you're given an equation, you can just plug the value into the equation and see what you get. So keep that in mind. Let's look at a couple more. You can look at it, you can also do the graph. If that makes more sense to you, that works, that's fine. When there's only one equation here, easiest way probably just to plug in that number right there. Okay. How about when we look at this E graph? Do you remember how to graph E's? E to the whatever? So remember, E is a number kind of like pi. It means 2.718. You also have an E button in your calculator. And so if you do e to the 0, anything to the 0 power is 1. E to the first, 2.718. E squared gives you that. Anyways, just 3 points should give you an idea of what this equation looks like. And yes, there's a horizontal asymptote here. That's some algebra 2 knowledge coming back at you. But we have a normal, like a shape for an exponential graph. Remember, that's what the shape looks like. You should have an idea of what an exponential graph looks like, whether it's 2 to the x, 3 to the x, 4 to the x, in this case, e to the x. All of those have the same shape. Okay, so let's look at as x approaches 0. So here's 0, it's the axis. As my left hand is approaching, I'm getting really close to this y value of 1. As my right hand is coming down the roller coaster, it's also getting really close to 1. And so there we go, plug that in, and you get 1. That's what the graph looks like, but just remember, this is just one equation. When you're given just one equation, what you can do is just plug in the 0 for the x. E to the 0 is 1. Remember, that was the same thing as the limit. So when you're given one equation, again, you can look at the graph if you want to, but it's probably faster to just plug in the x value. That's what we're talking about when we say when you're given an equation. You don't always have to look at the graph, although a lot of times it helps. Okay, let's do one more. I'm going to do the shortcut here. Again, this is just one equation, and so what I can do is just plug in this 4 right there, and I get 2. Cool. But let's look at the graph, and let's just make sure that makes sense. The square root graph, remember I call it what it looks like is a sprinkler. It has an endpoint. When you plug in 0 here, you get 0. That's why that first dot is right there. You cannot plug in negative x values, which is why there's no arrow this direction. But when I plug in 1 to here, I get 1. So there's my second dot. I don't want to plug in 2 or 3 because those would be decimals and I just don't feel like graphing decimals. But another easy number to plug in here would be 4. And when you square root 4, you get 2. So there's our third dot. And now I remember, oh yeah, this thing looks like a sprinkler. Anyways, as I'm approaching 4, here's where 4 is. As I'm approaching 4 from the left, my left hand is getting closer and closer and closer to this y value of 2. Also, my right hand is getting closer and closer and closer to this y value of 2. And so in that case, left hand and right hand meet at 2. The graph always works. However, just remember, if you're given an equation where it's defined everywhere, you can just plug in your limit number to the equation. Either way, you get an answer of 2. Okay, that's a little bit more Algebra 2 for you guys with a few more examples and things to look at. So now get started on the worksheet and make sure that you send me an email or message me somehow if you have any questions. Thanks for watching, and I hope you have a great rest of your day.